So this question is a graphing question, and we're largely going to be answering it on our GDC or graphic calculator. So the first part is that we need to sketch the graph, and it tells us where we need to sketch the graph, which is this part here. So this is not something that you type into the calculator, we just type this part here. We don't even need this part. Okay, so that part's not needed, we just type this in, but it's telling us that it is not valid at 0, which means that there's going to be an asymptote at 0, and we can see that from this line here. And it asks us to plot the graph for x is between -5 and 0, okay, or -5 and 0. So that's this part here of the graph. So we're going to go to the GDC to do this, and we're going to go to the y equals, and you can see here, we need to clear whatever is in there already. So we have 3x squared, 3x squared minus, and then it's a fraction, 5 over x, and we can plot this straight into my graph. Now you can see at the moment mine does not look like the graph, so I need to go to window and I need to change my scale to be the same as it is on the exam paper. So x is from -5 to 5, so let's do that on our window, -5 to 5, and then our minimum on our y is -60 and it goes up to 80. So -60 to 80. There we go. So now if we graph it, we can see a much better picture of what's happening there. If you have something like this, then it's because your steps on your scales are too frequent. So we could change that to 10, and then you can see otherwise you've got like a line there for every one. So it's just too many. So we can see that the part we're graphing is the negative part, so -5 to 0 for the x values. So it looks like it keeps going up here, which is an asymptote, which makes sense to what we saw in the question with the asymptote. And then it comes diagonally across. Now we do have some sort of minimum point here, and we want to draw it accurately. So it's probably going to be best if we find that first. And if we look, the next question is to find the minimum point. So if we go second function trace, we can find the minimum value. And if we come across there, it's from here all the way across to here, which is a, it only asks for the x coordinate. So the x coordinate there is -0 point, is it 5? Oh, that's not actually found it yet, has it? There we go, -0.941 to 3 significant figures. So that means that it's almost at the 1 point, but not quite. So I now know, and I can also see here from the y value that it's at 8. So I can see that it's around about here for my minimum point. It doesn't need to be exact, but it needs to be a rough idea and putting it in the right place. And then we can see that the graph comes in from this side and comes across to find the asymptote. So we now need to use the GDC to find solutions to the equation f of x equals 20. So we're going to use the y value and we're going to plot the value of 20. And we can now go back to the graph and it's drawn that line on, and we need to find all of the solutions when f of x is equal to 20. So that's wherever these two graphs are equal. So we're going to go to our second function trace and find the intersections. And we're going to go across to the first one. So anywhere on the blue line near it, and then the red line near it. So you're selecting the two graphs in the right area. And we can see there that the solution is x is equal to -2.45 to 3 significant figures. There's no y value, so we don't need to put the y value because our function here only has x in it. There's no y. Then we can find the next one. So again, we look for the intersection, and the intersection is this one here. And again, and we can see there that we have a second solution at -0.252. And then the last one there is second function trace intersection. And if we keep going across, so I'm just using my right hand button here, somewhere near to that intersection on the both graphs. We press enter again, and we can find we have a third solution at x equals 2 and then that's going to be 70 to 3 significant figures. And then the last one is to write down the equation of the asymptote, and we actually talked about that earlier. It's x equals to 0. X equals is any vertical line, and we can see it in the question, and we can also see it on our graph there, where you can see that the graph is going close to it but not touching it on both sides.